Okay, everybody, we're going to start our second lecture, the utilitarian types of light sources. These are the types of light sources that we use every day. Um, but before we get started, I want everybody to open up your two documents, your short answer and multiple choice text document, and your long answer lists and diagrams document, and have those ready. Pause the video, write down questions as we go. Then you only have to watch it once. However, watching it twice, you can speed it up, watch it at double speed or something can help too. Make a lot of questions that way. And I'm going to ask you for some of those questions towards the end of the lecture. So make sure you're taking them. Okay, before we get started into this, I want to make sure that you guys understand how important light sources are. I only recently have had this revelation or this idea where when you're walking around at night or if you're doing some work or reading at night, that's something that is a luxury now that didn't exist for a long time. For a very, very long time, fire and sun were the only two ways that we could get light. And when it became dark, productivity would decrease because you couldn't do certain things. Now that doesn't exist, which is awesome. It's we've kind of defeated darkness in terms of we can do work and practical, mechanical things all the time, right? You can do research. If you wanted, you could stay up all night and read and get smarter. And as a species, I think that's really, really important. There was a video that I was told to show a class when I was substituting called CBC's Top 100 Canadian Inventions, and the light bulb was in the top three. It didn't win. I think it should have because I think all the other inventions kind of need the light bulb to exist for those people to make those things, to become smart enough to make those things and have time to make those things. I guarantee you they use that light bulb. So I thought that was kind of a neat way of thinking about light and the fact that we have kind of obsoleted darkness now. Okay, so our first source is incandescent sources. And this is when an object, usually metals, can be heated to such high temperatures that they emit light. So if you think about like red hot irons, or if you ever had like a bonfire and left a poker in the fire for a little bit, it becomes red hot, right? Or if you've ever seen a blacksmith work, those metals will start emitting light, generally red or pink light, orange light. This is called incandescent light. So we often see these in light bulbs, although they're not that common anymore, incandescent light bulbs. Uh, Candle flames and any combustion reaction are considered incandescent light. So incandescence, this is a definition, the emission of light due to heat. You'll notice this is an incandescent bulb. The blue is 71 Fahrenheit. The red is 347 degrees Fahrenheit. You'll notice it gets very, very hot. Um, so incandescence is by nature kind of a maybe a little more dangerous because I don't know if you guys have ever changed an incandescent bulb, but if it was on for a while and you forgot and you turn it off and go to change it, you're definitely going to burn your hand. So in light bulbs, we heat the filaments until they glow, and the filaments are these little kind of wavy things here. That's a metal that is sometimes tungsten, sometimes something else, that we run basically electrical current through, and then it heats up and it emits light. So the transformation of energy, is electrical energy gets converted to thermal energy, which results in light energy. But 95% of the energy given off by light, by incandescent lights, is heat, and it's not very efficient, right? If most of the energy is stuck here, if most of the electrical energy we're inputting is stuck as thermal energy, not much of it is going to become light energy. So we're going to be wasting a lot of energy using this kind of light source, but for a long time that was the type of light bulb that was used. Fluorescent sources we see fairly often. Fluorescence is the glow you see when you go glow bowling, it's the result of UV rays hitting particles, which increases the energy in those particles, and that causes them to glow. So those particles will get energized and move up an energy level, and eventually they'll drop back to their normal energy level, and when they do, they release a little bit of light. Okay. So our pathway for this is we put ultraviolet energy in. The energy is absorbed by whatever fluorescent material we have. And that fluorescent material releases that energy as visible light energy. So the crux of it is we have a material that is absorbing ultraviolet and converting it to visible light. So you've probably seen these every day when you go to school. You might have some in your home or your apartment. And fluorescent lights are a really, really common light source kind of in big settings. So that's often why we see them in schools or buildings, stuff like that. But they do have some pros and some cons when you compare them to an incandescent light source. The pros are that there's very little heat production. They still warm up, uh, but when you have one on and you're going to change it, you can change it as soon as you turn it off. Like it's a little warm, but it's not going to burn you. Maybe wait a little bit just to, for safety's sake, but they don't get nearly as hot as incandescent bulbs. And this means that they're a little more efficient. They're not wasting a lot of energy as heat. Most of the energy is being transmitted as light, which is what we're trying to do with these. And some cons is that they can contain toxic chemicals. There's different ones, but generally the ones that are the ones we're talking about have mercury in them. They're very expensive to make compared to an incandescent bulb, and they're a lot more difficult to dispose of because of those toxic chemicals. Um, you don't want to go around breaking these and inhaling any of the fumes or anything that come out of them because they're poison. So they're a little more. I guess another con there is that they're a little more dangerous in some ways. Incandescent bulbs can be fire hazards or can burn you. These though have some toxic uh, properties to them. So the way a fluorescent source works. Hey, look, a diagram. You should maybe know how to draw this. The way a fluorescent source works is that we've got an electrical current coming in here to this electrode, and that electrical energy gets absorbed by the mercury that's in the tube. And when mercury absorbs that energy, it gives off UV, or ultraviolet energy. And that ultraviolet energy goes to that kind of white coating that's on these glass tubes. And that's why most of these are white, is it's white phosphorus. And white phosphorus, when it absorbs UV, fluoresces, turns into visible light energy. So that's the pathway for this one. This is by far the longest pathway. So don't worry, it doesn't get more complicated than that. But good pathway to know, good diagram to know. Pretty easy questions to ask about this. Try and make some. And the last one that I want to talk about is LED lights. So this I don't think is in the curriculum because these were not popular before the curriculum was made, but now they are very, very popular, and for good reason. LED stands for light emitting diodes, and they work similarly to incandescent bulbs in the sense that they have kind of a filament that we're running a current through, an electrical current through. But instead of a metal conductor where we're heating it up really, really high, we use semiconductors as filaments, which is a material somewhere between a conductor and an insulator. We'll get into that in a little bit later. But we use these semiconductors that they light up very quickly, but they don't produce very much heat. Okay, so they produce a lot less heat than incandescent bulbs, which means that they're much more efficient. We put in electrical energy, and most of that energy is released as light energy. So the semiconductors, the reason this wasn't used a lot before was these semiconductors were expensive or rare, and eventually they kind of got more common. We found more of them, or maybe there's some other economical reasons, like maybe there's a patent or something that ran out. I'm not totally sure. Maybe something to look into. But they became a lot more viable commercially in the kind of recent last couple decades or something. And the technology has advanced to the point where at first LEDs were all this kind of like cold white light. Here, let's maybe blow this up. So at first, LEDs were always kind of this cold white, and it wasn't very pleasant because you'll notice if we look at incandescent light, it tends to be fairly warm and orange. And if we look at fluorescent light, kind of that cold white. And I don't know about you guys, but I get headaches when I look at that kind of stuff for too long. So a lot of LEDs when they started were this cold white and not super pleasant to look at or to have in your home. But then now they range from like super warm to cold. And LEDs are used in a lot of stuff other than just home lights, right? A lot of Christmas lights are used like that. There's car LEDs. A lot of electronics use LEDs, like TVs and stuff, phones. So LEDs are super flexible. They don't create a lot of warmth, which is good, or a lot of heat, which is good. Uh, and they're super cost efficient now. I do believe that they are still more expensive than other bulbs, but they last a lot longer, so they kind of balance out, I think. Um, so yeah, this is, I would say, the winner of the light bulbs right now. It's the one that is becoming the most common, becoming the most efficient. And this is a pretty decent chart comparing the efficiency, longevity of each of these. Here, maybe let's blow this up too. So candlelight, not very efficient because it gives off a ton of heat. The lifespan, also very short if that wick burns out and it's toast, right? The color rendering, you can look into that. We're not going to worry about it too much. It's how accurately colors are shown under this light. It's kind of a weird thing, the CRI, it's the coloring rendering index. So you can check that out if you want. It's interesting to learn about, but we don't need to learn about it right now. Incandescent bulbs, a little more efficient than candlelight, last longer than candles, good color rendering as well. And CFL, this is a fluorescent bulb. Fluorescent bulbs sometimes look like this little curly Q thing. Sometimes they're the long tubes. They look a bunch of different ways. They're fairly efficient. They have a significantly longer lifespan, so even though they're more expensive, their lifespan might justify it. But their color rendering is not so great. So, like I said, the quality of light from those things is maybe not as desirable. And then LEDs are, you'll notice they actually have a plastic housing here because they don't create heat. You don't have to, or they don't create much heat. You don't have to worry about it melting. So they have quite high efficiency, really high lifespan, and good color rendering. Shrink that back down. Okay, so that's the end of this lecture, guys. What I want you to do, what your assignment is today, is to post a question from your list of questions that you made as a reply to this assignment, and you are not allowed to post a question that somebody else has already posted. So I hope you're up early watching this, I suppose. All right, cheers.